Hey kids, this is Mr. Cozy and this is video 36. In video 36 we are talking about rational inequalities. Let's get started. The good news is that solving a rational inequality is almost exactly the same like solving a quadratic inequality. In fact, I'm going to start out solving this problem in exactly the same way I would if this were a quadratic problem. I have two factors, so I make a sign table using those two factors. This top factor is 0 when x is negative 3, so I mark that on my sign table. This the factor in the denominator is 0 when x is 6, so I mark that in my sign table. Now, because this factor is in the denominator, I'll need to remember that for later, so I'm just going to circle the 6 to remind myself that the 6 makes the denominator 0. Okay? Because that's going to be important to remember for later. From here, I have a number line in 3 regions. I pick a number from each region. Some number less than negative 3. Let's say negative 4. Some number between negative 3 and 6, let's say 0, and some number greater than 6, let's say 7. Okay, so plugging in negative 4, I'm going to have negative 4 plus 3 is a negative number. Negative 4 minus 6 is also a negative number. Negative times a negative is a positive. And, I'm sorry, negative divided with a negative is a positive. Okay, plugging in 0. 0 plus 3 is 3, positive. 0 minus 6 is negative 6, negative. A positive divided with a negative is a negative. Plugging in 7. 7 plus 3 is 10, positive. 7 minus 6 is 1, also positive. Positive times a positive is a positive. So I have 3 regions. I'm positive less than negative 3. I'm negative between negative 3 and 6, and I'm positive when I'm greater than 6. Okay, I want to be greater than 0. That's positive. So I want these 2 regions. So my intervals are negative infinity to negative 3, bracket, because I can be 0, union 6 to infinity. Now the 6 would normally have a bracket. Here's one of the differences between rational inequalities and quadratic inequalities. In a rational inequality, this is a fraction, and in a fraction I can't have 0 in the denominator. When x is 6, this denominator is 0. That's why I circled it, because I can never have a 0 in my denominator. And since 6 makes the denominator 0, I circled it to remind myself to always give 6 a parenthesis. Always, 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 always. Okay? This is one of the differences between rational and quadratic inequalities is that any factors that are in the denominator, you have to remember what makes them 0, because you always have to put a parenthesis on that number in your answer. You can never include that number in your interval. Let's take a look at a more complicated example. Let's take a look at x squared minus 3x minus 10 over 1 minus x is greater than or equal to 2. I have a problem here, and my problem is I need a common denominator. I can subtract this 2 to the other side, but I need to be super careful, because that 2 is currently over 1. I can't combine it with this fraction. To combine it, I need a common denominator. My LCD is 1 minus x. This needs a 1 minus x in it. And what I put in the denominator, I have to also put in the numerator. Okay, this is still greater than or equal to 0. And now I can solve this out. This is x squared minus 3x minus 10 minus 2 times 1 minus x over 1 minus x. I should work in this is greater than or equal to 0. I should then simplify my numerator. So I'm going to have x squared minus 3x minus 10 minus 2 plus 2x. 1 minus x. So collecting like terms, I get x squared minus x minus 12 over 1 minus x is greater than or equal to 0. And I've got to factor my numerator now. Having all three factors, I can now make my sign table. Okay, this factor is 0 when x is 4. This is 0 when x is negative 3. This is 0 when x is 1. So I've got to mark 4. I've negative 3, 1, and 4 on my sign table, and I've got to circle the 1 because it makes my denominator 0. So I now have 4 regions to test. I've got to pick a number from each region. Let's say negative 4, 0, 2, and 5. Then I've got to plug in each number and test it. Guys, tonight I want you to finish this problem. Plug in each of these numbers, see when the factors are positive and negative, and decide if the region is positive or negative. I'll get you started, and I want you to finish it. Plugging in negative 4. Negative 4 minus 4 is negative 8. It's a negative. Negative 4 plus 3 is negative 1. Negative. Negative 4, 1 minus negative 4. 1 minus negative 4 is like 1 plus 4. That's positive. 2 negatives and a positive make a positive number. Okay? Now do this for 0, 2, and 5. And then decide which of these regions you should have in your answer, knowing that I want my answer to be greater than 0. Okay? Do this tonight. We will talk tomorrow. Have a great evening, and I will see you later. Bye-bye.